Thanks very much. A little bit taken by surprise because I sent in a video for this, so this is going to have to be very much off the cuff. So I apologise, it might be shorter than planned, but we'll see how it goes. Thanks very much for the opportunity to speak to you today. My name is Stuart Sneddon. I'm a Technical Director at Ricardo Energy Environment. As you said, I've been working in the sector for quite a while, and I'm focusing particularly on areas for Ricardo, looking at real-world vehicle emissions and how we can make the best use of data from that source by linking it to some of the tools and information that Ricardo holds to get us better insight to authorities and clients and users on what's impacting air quality and how we can make successful improvements. So next slide, please. A lot of my presentation is focused around the who, what and why. So in this case, it'll be the who, why and what. Firstly, introduction to Ricardo, for those of you who don't know it. Ricardo is the UK's top air quality consultancy. We've over around 150 air quality consultants working on air quality day in, day out, covering a wide range of projects and programs, but also a wide range of research as well. We operate and support a wide range of headline projects, including the National Atmospheric Emissions Inventory and Greenhouse Gas Emissions Inventory, the sections of the Automatic Urban and Rural Network, modelling ambient air quality, and also providing wide-ranging support to European Commission, Scottish Government, Welsh Government, and a huge number of local authorities. We provide support to over 250 authorities in the UK and in cities in the UK and internationally, and have undertaken a huge amount of clean air zone and low emission zone work, which is important as we move into different sections today. What I'm going to talk about largely is an area of focus that we're looking at, which is real world vehicle emissions. We've all heard about the Dieselgate scandal and the impact that has. So we've been looking at what the vehicles are actually emitting on the road, looking at different impacts of different environmental and different sections. But we also provide a wide range of support across the air quality sector, from measurements, emissions, modelling, policy and innovation, but also importantly, how we change behaviour. So including in that awareness raising programs, websites, and also education. Next slide, please. So first of all, why? The evidence around air quality and impacts on health is substantial, and our awareness and the evidence and understanding of it grows daily, and that links to some of the information that came out and the new guideline values that were sort of released by the WHO recently. The reality is, whilst we've made significant improvements over the last 5 or 6 decades in improving air quality internationally, people are still dying from air quality. And in the UK alone, poor air quality is recognised as the largest environmental risk to public health, and the substantial costs that has on the economy as a result of that from air pollution as well. So the thing is, next slide please, the important thing is we need to try and look for ways to do things more effectively and do things better wherever we can, which is focusing on some of the innovation I'm going to talk about today. Next slide please. So I'm going to talk to you, there's a number of research avenues and innovation that Ricardo is looking at, and obviously road transport is the focus of much air quality research in the UK because it's still the principal source responsible for most of the AQMAs in the UK. And so a couple of strands of our innovation have been focused around that specifically, but also have been tailored to the needs of our clients and partners. What can we do more of to get better insight into what air pollution is? So in terms of feedback from our clients and what we've learned over the times that Ricardo's been in existence, the quality of the outputs, we need to make sure that whatever we are generating has been tried and tested and used in practice, and that is something that we are quite focused on doing. We want to try and, wherever possible, maximise the use of available data sets to improve air quality. Authorities and agents and individuals collect a wide range of information for a wide range of purposes, and some of that can or may potentially be used to support air quality evaluation and support improvement activities. We're looking to try and include the best data sources available to improve the evidence base that we've got available to make decisions that inform and bring about improvements. And some of the feedback we've had is for policy users, policy and decision makers rather, is to try and get more information, a better understanding of what's going on and what impacts that mitigation measures will have in a near real-time system. We don't want to have to wait weeks, months, or even a year to find out if what we're doing is actually going to make a positive impact on air quality. Importantly, for a lot of what we do, it's not just about what we can do, but it's empowering authorities with and policy decision support and awareness raising tools to allow them to make the best decisions possible. So we appreciate any feedback we get and try and work closely with our partners as possible. Next slide, please. So in terms of innovation in effective air quality management, as I said previously, authorities have access to a wide range of data sources that can be used to drive improvements in air quality and support informed evaluation in near real time. Two of those data sets that we're particularly interested in are traffic data feeds, including AM data, which is lots of cameras being put in for different purposes, including clean air zone or low emission zone enforcement, and also lower cost air quality sensor data, which is useful for informing modelling outputs and getting a wider understanding of what the air pollution climate actually is. We've been using those information sources to support parallel aspects of work that we're doing with real-world emissions database that we have at Ricardo, and also Ricardo's Rapid Air, which I'll talk about in a little more detail, to generate an urban air quality management system which is more responsive and quicker, able to respond to what information is actually being fed into the system in very short term, to provide users with an opportunity to modify behaviour and make decisions that will bring about sustainable improvements. Next slide, please. So Ricardo has undertaken a real-world vehicle emissions remote sensing program and offers it as a service for the past 3 or 4 years. There's been a particular focus on it. One of our colleagues, Dr. David Cardwell, leads up the work for Ricardo, and it's based on sort of most of the. There obviously is a significant difference between for many vehicles in terms of what the vehicles emit in the lab versus what they do in the road. Now, a lot of thanks needs to go to the team that actually spend out doing the remote sensing, because it's nice to look at the data and that brings a lot of value, but a lot of them have to be out on the road actually undertaking the measurements, and sometimes under quite uncomfortable conditions. Now, the character on the left here isn't a part of the field team. He's just, and despite the fact he's quite shocked about what's going on, it's really just to sort of raise the evidence and the elephant in the room, that we, despite having an awareness that the real world emissions from vehicles are generally much higher than what we report in the lab-based emission factors, these factors are still being used to inform the decisions that we make in terms of what are the actions we should take to improve air quality in many of our towns and cities. So next slide, please. So Ricardo has been undertaking a real-world emissions sensing program, as I say, for the past 3 or 4 years. Over that period, we've got around about 600,000 measurements of vehicles across the UK on the emissions they're generating out on the road under real conditions. The technique of using UV infrared beam measures emissions of different gases that they absorb at different wavelength regions, so we can provide measurements of NO, NO2, CO, hydrocarbons, PM, and ammonia. We also measure the vehicle speed and acceleration of each individual vehicle, and we capture the number plate so we can cross-reference that to the database. So we know what vehicle type is, make, model, age, Euro category, and we can allocate an emissions associated with that vehicle type and aggregate that data based on the number of measurements we have of the same type of vehicle. Next slide, please. So we've used the remote sensing work that we've undertaken to support a wide range of programs, including research, and some of the slides and the figures on the left here, sort of giving you an indication of each of the individual dots in the top slide, give you emissions based from a specific make and model of vehicle, and the sort of the steps there you can see are the type approval emissions data. There's simply from that you can see the real world emissions are significantly higher than what we'd expect from the lab-based emissions data. And this is sort of pushing the direction of travel that we're going at, how we use this information to inform better improvements in air quality in our towns and cities. We've also used the remote sensing equipment to support some evaluation of vehicle emissions performance. Notably, we supported EST and Transport Scotland in a programme recently looking at the emission performance of bus retrofit technology in cities across towns and cities across Scotland. So it's been used for that. Next slide, please. We've also used it to support a wide range of authorities to improve their local air quality management, give them better information what the local sources of pollution are in the real world, so that they can guide improvements in the low emission zones, also the air quality action planning, and try and target the vehicles that will bring about the most significant improvements in air quality if we can address the pollution that's being produced. Another aspect of it is supporting the emissions inventory development, and I've sort of referenced a paper from some colleagues here on the right-hand side. And this is an area that Ricardo and our partners are actively working in to try and generate real-world emission factors that can be then used to inform dispersion modelling and provide a better inventory and emissions output to support real-world emissions and air quality management. Next slide, please. The other element of the management system I talked about earlier is Ricardo's Rapid Air, which is a cutting-edge air quality modelling system. Ricardo's Rapid Air has been developed since 2012 and was initially developed in response to the needs of our clients who wanted to look at air quality emissions and concentrations across large geographical areas, megacities, undertake detailed scenario analysis, but not have to wait days, weeks, or even longer to actually get detailed results. The big difference for Rapid Air is it performs the same as any of the modelling systems that most users might be aware of. The difference being it is really, really fast. We can model sort of London, Greater London, in a matter of minutes at a couple of metre resolution with no problems at all. It's been subject to independent peer review, and it has been proven in application. We've used it in clean air zones and city scale modelling in the UK and internationally. It's also been used to be linked to sort of traffic simulation modelling software at strategic level and at microsim to support sort of strategic planning processes as well for authorities, including Leicestershire County Council. What we've been using in this system is to link our real-world emissions factors and other data sets to Rapid Air to generate an active air quality management system. So we have a breathing model effectively, which we've classified as air quality now. And I think having information which is available to users, the public, and policy and decision makers in near real time is something that could be hugely valuable. Next slide, please. So bringing these two bits together, next slide please, it might highlight something hopefully. We have effectively three columns here. The middle bit is the real world emissions database, which I talked about a few slides ago. On the right hand side is the Rapid Air, where we can visualize information, generate some lovely plots, and give us useful information on source apportionment. The key element we've been trying to link that with is the traffic data, the most detailed traffic data we can get access to. Information on flow, speed, composition, make, model, Euro category, and age. By linking these data sets together, we're generating a near real-time, very detailed and proven air quality management system. Next slide, please. So this is sort of some of the outputs we've got from it, and this gives you some of the emissions outputs, and this is by linking to ANPR, sort of near live ANPR traffic feeds. You can get a detailed near real-time traffic emissions, vehicle emissions, and modelled concentrations. So it generates an active air quality management system, which users will be able to access and play around with and actually use to interrogate different scenarios that they want to use effectively to support air quality improvements in their towns and cities. Next slide, please. So very briefly, in closing, we believe this is a really exciting innovation in urban air quality management. We've gone through the process of trying, testing different elements and are linked it together. We're looking for opportunities for authorities to maximise the value from existing traffic infrastructure. So if you have traffic cameras for clean air zone or low emission zone enforcement, use that, try and see if you can use that information in a wider way to bring about improvements in air quality. The remote sensing of vehicle emissions, it really provides powerful insight into urban emissions. We've already talked a bit today about how road transport is the main source of emissions, certainly for NOx in towns and cities. And it's important that we have the best understanding of what the local emissions are and what the local sources are to provide the most effective solutions and bring about improvements. We're currently testing the system. As always, we go to the nth degree to make sure that the system is working and delivering what it should. And we'll hope to have some live demos scheduled for November. I'd also like to take this opportunity to raise the fact that at the right-hand side of that screen, that the Rapid Air software system will also be launched as a cloud-based system in the next few weeks as well. If you look for any information on any of the other slides, both the real-world emissions or Rapid Air, please do get in touch. I'll be happy to talk through anything with you and see how we can support you. Next slide, please.